Yep.
There we go, recording in progress. Okay, well, Roger asked me to do a couple of sessions at some stage on some of the analytical stuff on what I do. I tend to be more behind the scenes, so I'm not active on Facebook, which is why I've not met many of you at one time or another. But I deal with the actual data in the database and quite a lot of analysis of the database. So this evening I was going to talk about trends and what they are and how we calculate them. So I was thinking of quite a lot of it being the tool I use most is R. So I'll say a little bit about R and then I'll show you how some of the stuff actually happens. And hopefully by the end of the session, you'll have at least some understanding of the way we've been calculating trends. I'm sure many of you will seen trends that Roger posts and so on. So what I was thinking of doing was switching over to some PowerPoint first, and then I'll show you some actual stuff running on. So if I share my screen. Okay, can you actually see that now if I load up the PowerPoint? Is that working for everybody?
Well, it's working for me, Stuart.
Good.
Yeah, I mean.
Okay, so trends. Well, the commonest sort of trends we see for British wildlife tend to be measures of trend in the abundance of various taxa. And the main taxa at the moment are birds and Lepidoptera. Bit of mammal stuff around, but some of the biggest ones at the moment and the most long running are things like the Breeding Bird Survey, which is of course the BTO, Butterfly Monitoring Scheme, which is butterfly monitoring, which is butterfly conservation, and the Rothamsted Insect Survey. Now, the thing about these is they deploy the same survey method at the same set of sites each year, and they do it every year over a lot of years. And all of those schemes basically count the number of species in various ways. I mean, Breeding Bird Survey and Butterfly Monitoring Scheme are transect walks. Rothamsted Insect Survey are light traps and suction traps. We don't have this sort of data for hoverflies. We're not collecting in an organized sort of way, and we're not collecting abundance data. So the data we do get are ad hoc records from the times and places of our contributors choosing, and those vary from year to year, and the contributors vary from year to year. And there's no ready way of recording abundance. I mean, various things have been suggested at various times, but I mean, it's a very hard thing to do to actually try and get any sort of measure of the abundance of the species. So we have the problem that the data suffers both geographic and temporal variation. And this shows you the number of unique records we've received each year. And by a unique record, I mean a unique combination of the species, the date, and the grid reference. So that's the number of unique records, which you can see has bumbled along at around the 20 to 30,000 a year until about 2013 when the Facebook page started, and since then it's gone through the roof. And last couple of years we've received well over 100,000 records. 2022 records are only partially in at the moment, so this runs to 2021. And similarly, geographically, you can see that it's very patchy, and it tends to peak where most people live. because clearly people mostly record close to their homes. A lot of records come from gardens or where people regularly go for walks. And places like the uplands, central Wales, the Pennines, much of Scotland, particularly the Highlands and Islands of the Northwest, are very poorly recorded. And a lot of the records from those areas come from people going on holiday and so on. And there are a few squares in Scotland where we don't have any records at all. I think there's about 12 squares we still don't have a single record from, out of about 2,870 something on land in Great Britain. I'm talking here about Great Britain, not Ireland. As Roger's just saying, we've been doing some stuff using Irish data. The Irish data is very sparse, so this is Great Britain. But clearly there are some obvious trends going on, and I can show you some of the sort of things that come out. So, for example, Regia rostrata. We got somebody who could do with muting their sound, really. We're getting a lot of funny noises. So, is there somebody eating their tea or something? Perhaps could mute themselves?
Yeah, Rosemary, can you mute your microphone, please?
I'll mute it. There we go. Muted.
Lovely, thank you.
Okay, so Regia rostrata before 1990 was a very rare species. And in the original Insect Red data book, 1987, it was classed as vulnerable. But from about 2000, it started to expand in this area from the Forest of Dean up through the Welsh borders. And by about 2005, it started being recorded in the area around around Peterborough and Northamptonshire, where it had never been recorded historically. And as you can see now, it's right up to the Scottish border. And if we look at the trend there, very obviously, a vastly rising trend, and you can see why that should be so. Similar story for Volucella zanaria. So up until 1995, majority of records were in the Thames Basin. There was a scatter along the south coast, and there was this colony in the Bristol area. And then about 1995 onwards, it went whoosh right through the country, and it's now up to Central Belt in Scotland, with become a common species up to about, I suppose, Mersey to Flamborough headline. Again, look at the trend, obviously rising very steadily. And at the opposite extreme, here's an example, Platycarus fulviventris, where it seems to have certainly thinned out. You can see the 1980, 90, I thought that was actually to 99. I might have made a mistake there. But anyway, the early range, pretty much the whole country, more thickly across the southern lowlands, which may be an impact of recording pressure. And it's still got pretty much the same range, but it's decidedly thinned out in that range. And if we look at the trend, that's the trend plot I come up with. One of the things we like to do is put all these trends together to give an overall impression. So if we can actually take trends for individual species and look at those that show a significant downward trend, a significant upward trend, or no significant trend, we get this picture, which is pretty in line with many other insect groups, like the Macrolepidoptera, like beetles, like other fly families, with the majority of species actually showing a downward trend, a fairly small chunk of species showing an increase, and then a fairly large chunk showing no obvious change either way. And if you add these together, so this is some sort of measure of how frequently hoverflies recorded given an amount of recording effort, you can see that that has steadily declined. This is between 1980 and 2021. And so it's showing us something which I think we'd all agree with from sort of field experience, that we're finding a lot less hoverflies for our effort these days, and it's getting harder and harder to find the blooming things. we're seeing less of them around the place and so on. So how do we get this sort of data is what we're talking about today from the recording scheme. Well, to actually calculate this stuff, I use a piece of software called R. It's a free open source program for manipulating statistical data, doing data manipulation, statistical calculations, and it's very hot on graphics. You can produce lots of really nice graphics. It's become by far the most widely used statistical package. You find if you look at citations in scientific publications, in 2020, it was the number of citation was twice the next two most popular packages added together. So it really dominates use of statistics in academia and scientific research. It consists of a fairly small core, with most of the calculation facilities being provided by add-on packages. And much statistical research now actually proceeds by producing R packages. So if you've got somebody developing new techniques and so on, almost certainly these days, they will actually present it as an R package. And there are huge numbers of packages available. I mean, when I checked a week or so ago when I was putting this together, there were just short of 19,000 packages available for R, and they cover absolutely any analytical technique you can think of. And if you start poking into them, there'll be loads of stuff you've never even heard of, certainly loads of stuff I've never heard of. And it's free, which is great. Its downside is R works through a command line interface, and that's not the way most people interact with computers these days. It doesn't have any sort of graphical user interface, and that makes it unfamiliar and it leads to a steep learning curve. And since about 2005, there's been an integrated development environment called RStudio, also a free download, that provides some of the resources that make it a bit easier to use and hold your hand a bit. And that's what I'm going to be using tonight. So if I switch out of PowerPoint, we can have a look. This is where I'm going to be working, a directory called hoverstats. And if we look at this directory called data temp, I have the hoverfly recording scheme database runs on a virtual machine. It uses software called Recorder 6. And what I do is I dump out a flat file of data in a comma separated value file. And it looks like this. We've got species, date, grid reference. And this is unique combinations of species, date, and grid reference. And if we go down to the end of the file, there's about 1.4 million observations there. And that file is 74 megabytes of plain text. It's in a directory called data temp because these are temporary files. Whenever I make any changes to the hoverfly recording scheme database, I just regenerate these temporary files. And they're what I use for most analysis. And if people ask us for data, which a lot of people do these days, basically this is the sort of stuff I'll generate and give to people. And we are getting those requests a lot at the moment. We deal with them pretty frequently. So let's fire up RStudio and see what you can do with this sort of stuff. So I'm using a version of R called R2.2, which is the current version. And to actually work with R, one of the things you can do is create a script, which is a series of commands, which R then does for you. So we'll start a new script file. And as I said, an awful lot of the functionality is provided by these things called packages. And you'll see here, if I go to packages, I have an awful lot of packages installed. And they're very easy to deal with in RStudio. I can update them, see if there are any new ones. They're all up to date. If I want to install a new one, I can just type in its name, click it and click install, and it'll be installed. Dead easy to work with. So I'm actually going to use a package called data table because you saw there were 1.4 million records. That can take a while to deal with. Data table is a way of dealing with very large data sets very quickly. So we will we'll use that. And as I type, you'll see it does completion. So I can just click on that. You saw that this data is in a directory called hoverstats data temp. So I'm going to set a working directory. And you can see command line, it uses quite abbreviated commands, which can make it a little tricky to actually learn these things. So I'm going to be working in this directory called hoverstats, and I want to load those observations. So I will say obs, and they are in data temp unique records.csv. And there we go. So if I run that little lot, and I can run this line by line, load the library, set the working directory, and read those observations, and there they are, 1.42 million records. And if we look at that, we can see we have species, start date, end date, and so on. And if we actually want to look at them, there are the records, and we can scroll through them, all the usual sort of stuff. Now you'll notice one thing we don't have here is a year. We have dates, and we actually have dates in 3 fields: start date, end date, and date type. This allows us to deal with people giving us records just down to the year or the month or year ranges or all sorts of other stuff. But to do an analysis of yearly trends, I really need the year. So the first thing I've got to do is actually get the year. So I can do something like now I can get the year by formatting a date. So I'll format the start date. And the format I want is just the year number, which is this percentage capital Y. Tells for the format function that I want to extract the year from this date field that I've loaded. So if I do that, takes a second or two because it's chewing through 1.4 million records. Peculiarity of data table is it doesn't refresh my environment here. I have to actually refresh it. But you can see it's actually added the year. But if we look at that, it's added the year as a character string. And I don't really want that. I want a number. So I've got to do one more step. I've got to make that into a number. I tell it to turn into a number. So we'll run that again. And you can see R actually carrying out the commands down here in this console. So if I hit refresh again and look at this data, year is now an integer. So it's what we want, a number. So what I'm interested in is the number of records per year. So this is something at least we need to start with. So let's do that. Now, you may have noticed I'm using this funny less than sign followed by a hyphen. This in R means assign to. It means assign that value to this variable. I could use equals and it would work, but it's not a good idea because R uses equals for other things and it can confuse it. So I try to discipline myself to always use this assign operator. So what we can do is we can say, I want to manipulate obs, and wants the number of records. Now there's a special character to do that, which is .n, and I want to do it by year. Now this in data table, the first field here before the comma tells it what data I want to select, and I want to select all the data, so I've left that blank. The second field after the first comma tells it how I want to manipulate the data, and then the third field after the second comma gives it parameters that are needed. So hopefully what this will do is it'll show me the number of records by year, and we've got this variable called nrex, and we've got a count of the number of records in each year. Now, if I want to have a look what that looks like, I can plot it quite easily. I can say what I want to be the x, which is the nrex year, and what I want to be the y. And if I run that, you'll see it's come out with a plot here, and something's not right over that. What have I done wrong there? We got some we seem to have reasonable data there. We've got years going right back to about 1600, which isn't quite what we want. So let's sort that out. What I'll do is I'll set a start date, start year, and I'll set an end year. Run those two, and I'll put in a selection here where I'll select the observations that lie in that date range. And remember what I said, the first thing that goes into these square brackets is how I want to select the data. So I can say year greater than equals to start year, and year less than equals end year. And then leave the second field blank because I don't want to do anything. I just want to select the data. If I run that, I've come down from 1.4 million records to 1.3 million records. Now, if I run those commands, I get something more sensible. Now, I don't particularly like this, the plot as it stands out. The dots would be nice to connect together with a line, and it would be nice if the y-axis was a bit more readable. So how can we do that? Well, one thing we can do is tell the plot what type we want. Now, to find out about this, I can just highlight something like plot and hit the F1 key, and it will come up with help for that command. And you'll see here the plot command, and it tells me about types. P for points, L for lines. So let's say type equals L for lines and see what that looks like. That looks pretty horrid. And the reason for that is because these points aren't in order. So really what I want to do is put them in order by year. And I can readily do that by adding a second command to this, which is to order by year. And remember, I'm telling it here how to select the data. So that's the first bit of the command. I'll leave the second bit empty. So that should now put them in order. So they go from 1980 down to 2021. And if we now run the plot again, we get a sensible line, and we can see how the data shot up recently. If I want to improve my axes a bit, I can do that fairly straightforwardly. I can set labels. So I can say X label is year. I can, for example, divide that axis by 1,000. And then I can say Y label number of unique records, and they're thousands. So if I run that again, now looks a lot nicer. We've got decent axis titles and we've actually got a wide scale we can read. You can see it's going up something over 100,000 records here. Okay, so we want to see what's happening for a particular species. We can do that fairly straightforwardly. Let's choose a species. I'll set a species. And let's have a look at that one we saw on the PowerPoint, Platycurus fulviventris. And what I want is the number of records for that species. So it's going to be essentially this command. So let's just copy it, save us some work. But we're now going to need to put in a selection criteria into there, which is species equals spur-name. And that should give us the number of records of that particular species for each year. So let's try that. And we can see we've got a relatively small numbers of records for that particular species. And obviously we can copy this command, change that to spur number and the same there. Take out the divide by 1,000 and take out the indication there. And now we get number of records, Platycurus fulviventris. But of course, if we go back to our previous plot, we can see that the amount of recording has really shot up. So somehow we've got to take account of that. So an obvious thing we can do is say, of those records that were received in that year, what proportion of them were Platycurus fulviventris? So we can see how the relative frequency of records of Platycurus fulviventris relative to the total amount of records we're receiving. So to do that, we need to add in this number of records, total number of records, into this SPN variable here, so we can calculate a proportion. And again, data table allows us to do that quite easily. But at the moment, we have a bit of a problem in that we've called the variable n in both cases. So if we merge these together, both of them are going to be a variable called n, and that's going to cause problems. So what I need to do first is to rename this one, call it total or something. And I can pretty easily do that by simply giving it a name. Again, if we run that, not clicked onto it. Now we've got total instead of n as the thing, and we need to modify that. Now we're in a position where we can stick these two variables together. And so the way we can do that is say, so we're saying we want to combine together these two variables, SPN and number of records, and we want to do it by this year variable. So if I run that, we should now find SPN has two columns. Oh, I got an error in there. Oh, sorry, I used the wrong syntax. It's not by, it's on. Yep. There we go. We've now got the total and the number of records, and clearly we can readily calculate the proportion, which is going to be n divided by total. and I'll multiply it by 100 to put it into percentages. So if we run that, we should now find we've got the year, total, number of records, and the proportion of records in percentage that are of Platycurus fulviventris. And all we need to do is change that to our P variable and change the Y label. We'll call it proportion, and it's percentage of records received. I probably ought to say unique records, but that'll get a bit long, really. So let's have a look at that. And you can see that's now showing us a fairly similar sort of picture to the one you saw earlier on the PowerPoint. So if we want to, what we can also do while we're at it is label that. So we can put a main title in and make that the species name as well. So if we run that again, you'll see it's now got a title of Platycurus fulviventris, which is quite nice. So it looks like we got a decreasing trend. So how would we actually test for that? Well, an obvious thing you can do is obviously do a straightforward linear regression trend through it. And we can easily do that. So I'll call it LR for linear regression. And we're going to fit a linear model. So the command is LM for linear model. And what I have to do is give it a formula. And the formula is our dependent variable, which in this case is P, and our list of independent variables. And this time there's only one. It's year. And the data we want to work on is SPN. If I run that, we can have a look at LR, and it's given us an intercept and a slope, and the slope is negative. Or I could get a bit more data back by doing a summary, and that's showing us that it's highly significant. Now, the plot command is what is in R is called a high-level plotting command. It starts a new plot, and it does lots of operations to plot these lines, plot the axis, plot the titles, plot the box around the whole thing. But each of these things, like plotting the points and plotting these lines and plotting these characters, are all available as individual plotting functions. And you can call those individual plotting functions directly. And if you do so, it doesn't start a new plot. So they'll be added as additional lines or whatever to this plot. So if I want to add that trend line, I can easily do so. And there is a primitive graphics function called AB line, which plots a line from its intercept and slope, the AB of the AB line bit. And it so happens, as we saw when I asked for what was in LR, just here, that actually gave us the intercept and slope. So all I have to do in here is put LR in there, and it will get the parameters it needs straightforwardly. Now, to make it stand out, I'll make its color red, and I'll make it a bit of a thicker line, so line width 2. So there's the trend line added to our plot, and you can see it's pretty well plummeting. Now, in this particular case, a linear regression trend line like that is not really a very good thing to do, because we're dealing here with proportions based on pretty low numbers of species. Obviously, the number of records of fulviventris is pretty small compared to the number of our records. Proportions are pretty tiny. And one of the assumptions of a linear regression is these deviations from the line are normally distributed around the line. That's what it's assuming. And given the type of data, that's very unlikely to be true. So I would, if we did some more testing on this line, we would probably find lots of problems with it. So I tend to use a different statistic for this, which makes a lot less assumptions. And that's the Spearman rank correlation. And what that does is it simply ranks the proportions, so 1 to 42. It ranks the years 1 to 42, and it does the correlation between those ranks. And that makes a lot less assumptions of the statistics. It's not worried about the distribution of the deviations from the line. And so for this sort of thing, we've tended to use that a lot more. So let's do that instead. So what I'll do is I'll calculate the Spearman's rank correlation. And we can do that using something called core test, correlation test. And again, we need to give it X, which is SPN year. And we need to give it Y, which is SPNP. I need to tell it the method is going to be Spearman. And if I actually look at, again, if I put my cursor on core test and hit F1, this will show, the help will show me a little bit about it. And we'll find for the Spearman test, it'll do an exact test, which is it's calculating exactly using permutations and things. That's okay for a limited number of variables, but we've got quite a large number of variables here, 42. And if you run an exact test with so many rows, a lot of the time you'll start getting errors. And so I really want to turn that exact test off. So I'm going to put in another parameter called exact equals false. That tells it not to do an exact test. So let's have a look at what that produces. So let's look at the results. We've estimated rho at minus 0.79. Rho is the Spearman's rank correlation, and the p-value is tiny, so it looks pretty significant again. Now we can no longer use abline because we haven't got a slope and an intercept. So we need to do something else. Now, if you think back to things like the breeding survey and the butterfly monitoring scheme, what they tend to fit a sort of trend line called a smoothing spline, a sort of slightly wiggly line that goes through the data. And we can readily do that. So let's try fitting one of these things. And you'll see we get smooth spline here. The parameters we need to fill it are the same. And the other thing you need to give it is the degrees of freedom, which is how much wiggle you get. If I set the degree of freedom at 1, it'll fit a straight line. If I set the degrees of freedom at 42, it would actually fit a curve that went through all those points exactly, which isn't quite what we want. It's not sort of generalizing at all. So we really want somewhere in between. And what things like the breeding bird survey and the butterfly monitoring scheme use is actually 5 degrees of freedom, which I've found actually works pretty blooming well. So I'll use DF5, and that will fit us a smooth line. Now I want to be able to plot that, so I need to predict using this smoothing spline what the results are for each year, and I can easily do that by saying, whoops, predict SPR, and now I can tell it what X values I want it to predict for, and those are actually start year to end year. Remember, I set up these two variables for the first and last year I wanted to analyze. And if I write them like that, start year colon end year, what we actually get is a list of the actual year numbers. So that should give me a prediction for each of the years. So if we run that, we've come up with X's and Y's, which is what we want. They're actually in a data structure called as a list, whereas you see these other things are in data structures called data tables or data frames. And it's actually a bit tricky to plot these. So I'm actually going to tell it to return that as one of these data structures called a data frame instead of a list, just by wrapping them in data frame. And there we go. We've got PRX and PRY. And I can now plot that very easily by saying lines X equals PRX, Y equals PRY. And again, I'll make it red. And I'll make it wider. Line width 2. Whoops. That's not what I intended to do. Okay. So let's try plotting that again and putting the a sort of wiggly trend line through it. And that's usually quite satisfying, really. Now, okay, we've done some statistics on it. We've seen that it's pretty strong trend downwards. How do we tell people looking at this graph about that? So it would be nice to actually make a label which says, you know, it's a significant downward trend, and to show people the statistics of that. And actually, just as I had main and put species name in, I can also put a sort of caption on the bottom called a subtitle. But to do that, I need to make a label to actually put in it. So I need to turn this information into a label to convey that information. And the way I can do that is if I start with the change, you know, increasing, decreasing, no change. So I'll start with a change, which I'll set to no significant change. Okay, we now need to test if that's true or not. So we've got this variable called core, which came out of our correlation thing. We've got here the p-value and the estimate, the value of rho we can use. So if I say if core and I pick out the p-value, if that's less than 0.05, so 95% significance, it's less than we'll make it less than equals to. Then we've got we're saying we've got a significant change. That's our measure of significance. Now, secondly, if our estimate is negative, then it's decreasing. If it's positive, it's increasing. So if core estimate is less than 0, then we want change to be decreasing. Else we want it to be increasing. So if I run that, we will see now the change value is decreasing because p-value was less than 0.005 and our estimate was less than 0. I can do a little more with that by creating a label. I'll call it LB for label, using another function called sprintf, which allows me to combine text and numbers. And I can write a message putting in tokens for where I want the numbers to come. So I can say Spearman's row equals, and then I want our calculation, the estimate to come in. So I need to put in a token for that, and it looks like this. What that says is put a floating point number in with 3 decimal places and however many places you need before the decimal place. So that'll be, in our case, 0.3 digits. I want to say what the p-value is, so I need another token, which will be, I will make 4 decimal places this time because tends to be a longer number. And then finally, I want to put this change value in, and that's a string. So the token this time is %s, which says put in a string. Next, I've got to give it the values I want to go into those tokens. And so they're going to be core, estimate, core, p-value, and ch. And if I run that and look at our label, Spearman's row minus 0.791, p 0 to 4 decimal places, and it's decreasing, and I forgot to close that bracket, so I need another bracket in there. And I can add that to the plot by saying sub equals our label. So run that little lot again. And there's our label, which says Spearman's row was negative, it was very significant, and it's a decreasing trend. So that's what it takes to get that far in doing these calculations. And clearly, if I wanted to look at different species, all I need to do is change the species. Let's look at Volucella as an area and run those few lines again. And there we go. Got a trend for Volucella zenaria. And let's just look at one that might not be doing anything spectacular. Surface torvus should probably do. And look at that one. And that's no significant change. Now, if I want to do anything with this, I can export this plot, I can save it to an image file, or I can copy it to the clipboard. So for example, I can do something like, I want it to be 600 pixels wide, 500 pixels high. I want to copy it to my clipboard, and then I'll go and send a email to my mate Roger, and he'll post that on Facebook for you lot to look at. So that's how we sort of tend to do these things. One thing while we're here to notice is look how jaggedy these lines are. When you actually plot on an ordinary screen where you're obviously drawing a dot or not, when lines are drawn, they tend to draw in these little bits of lines. They're called jaggies. And this is a really jaggedy plot, doesn't look very nice. So we'll come back possibly to how to fix that. It's something called anti-aliasing, and it's something that R doesn't do by itself, but you can easily get it to do by a package, which will change the way the graphics device prints. So I don't really want to send Roger that just at the moment. So where are we? Cancel that, and I don't want to save it. Okay. Okay, let's just go back to the PowerPoint for a minute. Now, one of the problems we've got with the hoverfly recording scheme, if you think about what we've just done, we've looked at the number of records per year for a particular species, and we've expressed them as a proportion of all the records received. And we're taking that relative proportion of number of records as some measure of how frequently people are seeing hoverflies. Now, the assumptions we saw earlier that our data is quite biased, both in time with this big increase in the amount of recording recently, and in space, because there's a lot more recording going on in the lowlands of England and Wales, and very little recording in the uplands, and very, very little recording going on in the Highlands and Islands of Scotland. So we know our data is biased. but we're assuming that it's constantly biased. So every year people are tending to record down here and not record up there, and that's the same for each year. And we could actually produce these plots for each year and sort of check that. Similarly, we're saying that some years we don't get many records and some years we get lots of records, but people are going out and they are doing their walks and they're recording hoverflies. So they might be biased in how they're recording, where they're going, but again, it's equally biased over a period of time. So we're making the assumption that people's behavior is more or less constant, producing us more or less a constant bias, and therefore that change in relative abundance is some sort of real change in the hoverflies rather than a change in the data we're getting. But unfortunately, I don't think we can really assume that, because what has happened over the past decade or so is we've had a massive change in the way people are recording. In the past, people used to go out with nets and things and pick up species and identify them under microscopes and pore over them and send us a spreadsheet. What's now happening increasingly, and since about 2019, well over half the records, is people go out and take photographs and they post those photos online, and you good people identify them, and Roger and people capture them and they go on the database. And what people are doing when they take those photographs is generally photographing the common and obvious and not photographing the more obscure and difficult to anything like the same extent. And you can see that quite readily. So if I take here a trend in blue using all records and a trend in orange using only our more experienced recorders, and they are people who we've had records of at least 100 species in this particular analysis, we'll see a deviation in the trends here. And in the case of Eristalis pertinax, the relative proportion of records from all records is considerably greater than from experienced recorders. This is a species that your average person who knows nothing about hoverflies but likes to go out and photograph things will readily see visiting flowers in their garden. So we're getting relatively a lot more records of this species compared to some others. So we're overestimating its relative abundance. Similarly, if we go to something more obscure and less photographed, in this case, Platychirus clypeatus, we see the opposite effect, whereas all records is showing much more of a decrease than our experienced recorders, although both are still significant declines. So all these photographers who perhaps don't even realize it's a hoverfly because it's small and black and lives down in the grass, don't find it very often because you have to go poking around the bases of grass in wet places to find it. So we get far fewer photographs of it. So we're seeing a relatively over-egged change in proportion. And if you look at the summary of trends comparing those two groups, the all records and the excluding photographic records, you'll see that the proportion of decreasing species is a little lower. It's still around about half. The proportion of increasing species is still the same. So it's moved species from the decreasing into the no change category, because we are overestimating the decline of some of these obscure things because they don't often get photographed, and we're probably seeing a spurious increase in some of the really photogenic species because they're the ones that everybody goes out and photographs. So what do we do about that? And really what we have to do is to use more complex analytic techniques which try to take some account of these differences in recorder behavior. And we have had, for example, a group in St Andrews, a group of statisticians who've done some work and have actually produced an R package, not surprisingly, which does something called general additive models, which actually try to separate the two aspects of recording, which is the occupancy of the species, which is the chance that a species occupies a particular location, from the recording side of things, which is the detectability of the species. How likely is it the species is detected? And to do that, you need to take a lot more data into consideration. And specifically, you need to start looking at the experience of the recorders. So measures like how many records have been received from that person, what proportion of those records are of more difficult and obscure species, and things like that. Include those in the analysis, and possibly things about the time of year they're going out and the sort of habitats they're recording in. So a lot more data. Of course, when you start doing that, the models get a lot more complex to fit. And in fact, the particular models they've come up with, we found quite often won't actually fit. They run for a long period of time and then tell you the model doesn't converge. Where they do actually work, we get some interesting results. I played around with it a bit. On average, it takes probably 30 minutes to 2 hours to fit a model for an individual species when I've tried it. It churns away for a very long time on my computer, which of course is not a supercomputer, and we don't have a lot of money to go away and buy Amazon Web Services supercomputing facilities and that sort of thing. So this is running on my computer at home. So if you sat there 20 minutes waiting for it to complete and it just tells you model failed to converge, it gets a bit annoying at times. So causes some problems. But clearly we have a need to move into more complicated techniques if we are going to understand what is happening at a time when clearly recorder behavior has changed. But I hope in actually running through that lot, you've got some idea of what we can do with the data. You've seen the main tool I use to actually do this. Obviously, this is not a tutorial on R. I've gone through this quite quickly and no doubt confused people no end, but in 36 lines of script here, you can actually produce quite a decent little graph here, which you could quite happily put in a newsletter or something. So it's not rocket science. It's not that difficult. It's easy enough to do. What I have done is recorded a whole series of screen videos where I talk through fitting things like phenology plots, species distribution, maps, things like that. And they are available. They're on Vimeo. And I think Roger has probably posted the links on the Facebook page before now, and clearly they can be posted again. So if you do actually want to get in any of this stuff, there are some resources there to help you. So if I stop screen sharing, you are screen sharing, stop share, that's what I want. Then I can throw it open to anybody who wants to ask any questions. Finish my coffee, which will have gone cold.
Right. Hi, Stuart. I enjoyed that very much. It reminds me that I need to refresh my memory of things like degrees of freedom and what that's all about. But you mentioned early on that you get a lot of requests for information. Who asks for it?
I would say recently it's largely been academic. It's been people working as masters or PhD projects on pollination related themes. But also we get requests quite frequently from places like record centres or people wanting to do local atlases or some sort of local newsletter, that sort of thing. I mean, Roger, you'd probably remember them better than I do, actually, but I know I've dealt with quite a few in the last year or two.
Yeah, it's probably worth mentioning that the big ones are CEH and the conservation organisations. We've just been asked for another download for the whatever it is triennial state of nature report. So anything pertaining to hoverflies in the state of nature report will be that data set. The only thing that one can say, though, is that whereas Stuart introduces a degree of caution into the trends based on some of the biases that we know about, I don't think the team that do state of nature do anything quite like that. So the headline figures from them will be a little bit different to our headline figures. But I think we've had 10 requests this year that I've logged. There may be more, but I've certainly logged 10 different requests this year. And what we do know is that some people have data sets that they then use on more than one occasion.
So do the state of nature use the data set, or do you do an analysis for them then?
No, they do their own separate analysis. They use people at CEH, basically. Gary Powney and Nick Isaac do those analyses.
I think they are largely using general additive models, and they are a bit more sophisticated than what I've shown you tonight, which is the simplest way of doing it that I've thought of, because that's the thing to present to actually start off, clearly.
Yeah.
But certainly there are more sophisticated techniques around which tend to get used to try to correct to what extent you can for some of these biases.
What does CEH stand for?
Centre for Ecology and Hydrology. So they include the Biological Records Centre that's based in CEH. So their headquarters is in Wallingford, which is where the Biological Records Centre is based. They also have a centre at Lancaster University, which is where the NBN is based. So the NBN team are CEH in Lancaster.
Okay.
Alan, did you have anything?
You sort of answered that. Was the question in a way that interested to know whether we think there's likely to be better techniques coming along the line to enable this, or is it just a matter of we need more computing power?
Well, the technique I didn't go into tonight that I tend to use most is a technique called Frescallo, which was produced by Mark Hill, who was the head of the Biological Records Centre until, I don't know, 10 years or so ago when he retired. That's a little more sophisticated. It uses a neighbourhood of squares which are close and similar to look at essentially the species accumulation curves in those neighbourhoods, and then combines those. That is still affected by changes in recorder behaviour, but not as badly as proportional method. And so I've tended to use that most. And I often exclude records based on photographs when doing that, or what I'd call casual records. So you could define a visit as the list of species that comes from a recorder going to a place on a date. So you can take the unique occurrences of recorder name, date, and grid reference, and then say, okay, how many species did they record? And only include the records where they recorded, say, 3 or 5 or more species. So the occasions when somebody just snapped Eristalis pertinax, you don't include. And all of those methods improve on that massive bias we've picked up in the last decade. But, you know, 10 years down the line, when we've got a long run of data based on those photographic records, we'll have a really useful data set for looking at what's happening with a really common species. And in many ways, those are the best species to be looking at because we get most records of them and the most widespread records of them. So things like what's happening to Eristalis tenax and pertinax and Episurfus bultiatus and stuff is of interest, and we will have a huge data set based on casual photographs when we've got 10 years of those to work on. They might be a little bit of a nuisance in terms of the analysis at the moment, but in a few years' time, they become a quite important resource. So keep them coming.
Yeah, I think that's the thing to really emphasize is that, you know, these data sets, what we've got actually with the hoverfly scheme data set is effectively 3 epochs. We've got the period up to around about 1980, which is primarily from museum specimens, and it runs at, I don't know, let's say 2,000 to 3,000 records a year from the late 19th century through till today, or to 1970s. Then
with
we've
big
got this,
dips during the wars.
yeah, there are also some quite interesting. There weren't anything like the numbers of people recording that there are today. So it's very, very patchy, but some very active people for short periods of time. Then we've got this period from somewhere around about 1980 through till let's say around about 2010, where a very high percentage of the data came from a very small number of people, many of whom did a lot of microscopy. So in that period, something like 50% of the data came from 20 people. And then we've got this further period of now somewhere in the order of, let's say, 10 years, where we've got probably 100 people contributing 50% of the data, and the volume of data is very, very much greater, so that we've got both better spatial coverage and better temporal coverage, which means that in effect, where we start looking at the trends, we have to bear in mind those 3 different paradigms. And of course, if we get another 10 years worth of really high quantity of data, we've then got maybe something like 20 years worth of volume, and it's that volume that makes it so powerful. So that's very much why, you know, we do encourage more people to record and more people to record more frequently, because those are the sorts of things that are going to pick up some of the more interesting stuff associated with the commoner species, that we're not going to pick those up without very large volumes of data. And they are, you know, arguably some of them might turn out to be the passenger pigeons of the future. If we can start picking up trends early, then, you know, one can start sending out warning signs a little bit earlier. But to do that, we've got to keep the pace of recording pretty well as it is, rather than take our foot off the gas. So, you know, Stuart and I at the moment sort of fairly central to the team. We're not going to be here forever. So what we do have to do is try and encourage other people to take over from us, and ultimately make sure that the scheme keeps running, because it's going to be very, very important over the next few decades to see what is happening and try to explain why it's happening.
Adam's got his hand up.
Hi, you kind of just started the conversation there, Roger. First, I'd just like to say, Stuart, thank you so much. I wish you taught me statistics at university. That made so much sense than a lot of things I was told. But also it's about that longevity. Me and Roger and a lot of the recording team have talked about in terms of the succession plan for the recording scheme, which is important in terms of identification skills, but it's important in terms of this kind of skill as well. And I'll certainly be checking out some of the Vimeo stuff that you've mentioned, but where I've got some statistical experience that was quite mind-blowing. Has there been any thought into maybe doing some courses to start introducing some of the team to those skills?
If there was a call for them, there's no reason why not. Obviously, there are logistic problems. There are places like Preston Montfort, which are set up with a room with multiple computers and so on, where you could possibly run things like this. But I mean, having had some experience with Recorder and trying to set up sessions, teaching people on that, if people bring their own machines along, you can spend the entire blooming weekend trying to get the blasted machines talking to each other and working and stuff, you know. Whereas if somebody's got a network set up with 10 computers on it in a sort of computing lab, you can readily put data sets and things on that local network between them, which people can share, have exercises and lessons set up and so on. So it's finding that sort of resource that's that would be necessary to do it. So it's a bit more complicated than the hoverfly identification training, in that it's rather more difficult to take our own gear around and set it up. We'd need a place that has a computer lab set up like that. But increasingly schools and that sort of thing have that sort of facility. So it ought to be possible.
Yeah, because there might be people interested, because like myself, I work full time, so my recording capability is quite limited. I can only go out and actually see hoverflies when I'm off, but I have time in the evening, and I do give that time in terms of extracting data from the Facebook site. But if I can do more in terms of the analysis of the data, if you taught me, I'd be willing to do it.
Yeah, I mean, these skills do need passing on, and as I said, the sort of biggest chunk I've done so far is to record the screen movies. But there's no, I mean, before I retired, I was the data analyst for the Joint Nature Conservation Committee, and I ran a number of courses on things like R and Excel statistics and things for people at work there. Obviously, we did have set up with multiple computers and so on. So I'd be quite happy to do it. But as I say, it's finding a suitable facility that would allow us somewhere with a number of computers networked together, suitable for teaching that sort of stuff that we need to find.
Well, I've made a note of that because it's something that we could actually make a call out to. I mean, if we put something on the Facebook group, for example, there may be people, you know, who are part of an education facility that would have that capacity.
Well, Preston Montfort has those sort of facilities, but you're talking about quite an expensive weekend.
Yeah, the problem with Preston Montfort these days is that the Field Studies Council has rather lost its way, I think. When we first set up our annual training exercises that Diptris Forum run, I rang around the Field Studies Council individual training centres, and most of them just said to me, well, yeah, you can come to us, but we'll charge you the full rate that we would charge for our training courses, you know, including our tutor time, even though you're bringing your own tutors. And I eventually got to Preston Montfort, and Adrian Bailey said, oh, that's a good idea. How about 50 quid for the weekend? Now, this was 1993. Now, his move was quite inspirational, because we've been there now every year since then for 30 years. Now, I don't think FSC will play that game any longer, because they no longer have the same sort of setup with centre managers. It's all managed centrally. You now have to, if there's a course you you pay for the course and then you have to book your accommodation. It's a pain in the arse. It certainly stopped me doing anything with FSC. But we could actually contact the obvious people to contact would be one or two of the local record centres. Some of them might have sufficient facilities for half a dozen people. Might be
Possibly,
able to do that.
yeah.
And in which case, you know, if we could find one that's closely approximated to a relatively cheap hotel, you know, a travel lodge or something like that, then maybe we could do something. So I'll have a look at it and see what we can do. We can ask around. We might have other contacts. Harry, you were going to say something.
Yeah, I was going to say an alternative approach would be to come up with a sort of series of written tutorials which people can download one at a time and try out on their own computers, maybe with a dummy data set to use. And then they wouldn't have to travel to a meeting or whatever and try to keep up with everyone else.
Yeah, I think it would be feasible to combine the sort of screen capture video stuff with some exercises for people to go away and do at their own pace following that. That might be a way of trying to do it, to, as you say, preventing the need to travel. But with most of these things, some face-to-face time always seems helpful. So
Yeah.
places like the Open University have their, you know, summer schools and that sort of thing, where you can deal with some of the more practical stuff and get, you know, help straight away, which always helps. But I think some sort of combination could be worked out. Yeah. Some people prefer videos, some people prefer written PDFs to follow, you know, depends on individuals. I must admit, I do like the screen capture videos as a way of teaching, that sort of thing. I find I use them a lot for learning stuff, but that's how I like to do it. But other people have different likes.
Well, we can repost the links that you've got, Stuart. Are they the sort of thing that we could also put on the Diptris Forum YouTube channel? Because then people could know that they would just go to that YouTube channel and download from there.
Well, I mean, the videos are just videos; they go anywhere. I mean, I use Vimeo for those. At the time, it was there weren't limits on amount of upload and that sort of thing. I think YouTube has freed up quite a lot since then, but
Right.
All these free accounts tend to have weekly and limits on the total size and length of a video and number you can upload weekly and that sort of thing. I don't feel like paying money for a paid account.
No. Well, except the only thing that we might look at is, again, this is something where, you know, the bigger societies ought to be perhaps engaging. I mean, it's something that we could look at with Diptris Forum. You know, if the money is not huge, then why shouldn't we? As far as I know, the forum now actually pays for the Flickr account that holds Steve Falk's photographs.
Yeah.
And well, I mean, as you know, I mean, we put in the royalties from the Wild Guide to do things like education. So, you know, there's no reason why some of that money shouldn't go into supporting that sort of educational thing. But
yeah.
I suspect we're probably not talking about a major issue from the YouTube perspective, because it's unlikely there's going to be that many, and we can manage the process of uploading them. But we can certainly look at it and do a little bit more on that. Would it, just out of interest from everyone that's listened in, would it be a good idea to talk a little bit about modelling at some point? Because
I mean, I'm quite happy to do a similar sort of thing on species distribution modelling. I've been planning for a long time to put a series of these video screen capture videos up on species distribution modelling, but it's quite a big and complicated topic, and actually getting hold of all the environmental layers is the big issue, and that's what needs the video time to actually cover. But I'm happy to do something like this if people want it, but it depends on whether you like this more techie sort of stuff rather than talking about hoverflies.
Well, it is midwinter.
True.
No, I'd definitely be interested. I've been fiddling around with R on my own a little bit the last couple of months anyway, so this is very timely for me. So I'd definitely be interested in more of this as well. I see no reason why we shouldn't do both as well, even if it's a smaller number of people. It's equally as important.
Yep.
Yeah. Well, I think it would be very useful. I mean, it's one of the things that that I think we need to do is to make sure that people understand some of the ways in which the data are used, because that may have a bearing on, you know, how people generate data, and that could be important.
It also makes it even more is the general understanding of how the data is produced when people look at it in the nature world is actually probably quite low, really, that they look at a graph and they go, well, that graph must be correct. But just the simple example of adding in photos can skew the data is quite a powerful example, really, of how you have to really be thinking about what you're looking at.
Yeah.
And species distribution models are great because they produce really pretty maps. therefore they must be good.
Yeah.
I mean, that is a really interesting point, and it affects so many areas of life. If you produce something on a computer, people believe it and they don't question it, and that's a real problem.
Yes, I think you're absolutely right there, Harry. I remember raising a question about some coastal process modelling with a team leader on one occasion, and commenting that I wasn't very happy with some of the interpretations. And Richard said to me, he said, "Yes, Rod," she said, any fool can turn the handle. It's understanding what comes out the other end that matters."
Yeah.
And that's really the crucial point, even with the stuff that Stuart does. I mean, you see some of his presentations, and his last slide is, "But can we believe it?"
Yes.
You know, and some of it, well, no.
Yeah. I mean, I get involved in a lot of planning applications, not from a professional point of view at all, but just because they're affecting me locally.
Yep.
And one we've got around here is the Wisley Airfield one. I don't know whether any of you have heard of it.
Yeah.
Yeah. This would be, it's going to be extremely damaging for wildlife if it goes ahead. Nonetheless, bug life are supporting it because they think they can put in a beeline, and Taylor Wimpey have given them some money. So, you know, it's a real problem. The area I tend to look at is the traffic modelling, because it's a very interesting subject, and the type of models they use are quite interesting. Won't necessarily give you the answer you need, but they're also easily manipulated. And when you have a consultant acting for a developer, that is very worrying. And what they produced this time was, it has been said to be one of the longest transport statements ever seen to go in their planning application, which is immediately meant to, you know, stop people from actually looking at it. But when you do look at it, you find it's full of holes, full of holes. So you have to then go back and say, well, you know, all this stuff is missing, or it's simply wrong. And that's the only way you can fight these things.
Yep,
But-
I'm afraid so. I mean, again, that's to some extent down to data quality as well.
Yeah.
You know, but also the assumptions of the model. I used to deal with economic forecasts for pork growth, and I questioned the modelers quite severely, because I said, look, you know, the reality is that yes, you're predicting 6% growth right the way into the 2030s, but on what basis? Because economies plateau and they have periods of growth, but it's non-linear. And you have these things called recessions that, you know, reset the balance. But the modelers were absolutely insistent that 6% was right. Well, the last 10 years have shown you it's not. It hasn't worked at all. So yeah, and that comes back to the point that Stuart's made about the degrees of variation within the data. So you just have to be aware of it. Okay, we'll try and does anyone else have any questions or thoughts or no? Well, hopefully that's given a little bit of an insight into some of the workings of the back room that Stuart produces and sends to me and says, what do you think of this? And it goes on the Facebook page. I'm sure there'll be a lot more. Should we, Stuart, how soon would you be willing to do something on modeling on SDMs?
Well, whenever you want, really. I mean, when you can organise it. I've got. I'm not going anywhere very much
The
for
future.
Near future. Yeah.
Remembering that we've both got to go to Belfast.
Yeah.
At the end of whatever it is, and
We've
do
got a certain amount to do on blooming wild guides and things.
Yeah, I don't think we're going to be free much before the end of January.
Yep.
How about somewhere around about the middle of February?
Yeah, well, it depends what else is going on, but we can come up with a date.
Yeah, does
People
that
are
sound
interested.
okay for the group?
Mhm.
Yeah, jolly good.
Okay, well, shall I stop the recording then?
Yes, and if you yeah, and then we can actually place the recording on YouTube or whatever. That's good. Okay.